So here we are going to discuss about the throttling and its effect on the entropy, temperature and enthalpy of the fluid. Throttling is defined as the sudden pressure drop of fluid due to some restriction in the flow. Some examples of the throttlings are given in diagram. First one is flow through the porous material. Second one is flow through the capillary tube. Third one is flow through the orifice, and fourth one is flow through the partially open valve. All in these cases, the inlet pressure will be more than the outlet pressure. The most important thing which must to be remembered here, that here the pressure drop is sudden. It is not gradual pressure drop as in case of nozzle. Therefore, flow through the nozzle is not throttling because in nozzle pressure drop is gradual. As we mentioned, the pressure drop in case of throttling is sudden, so it is a fast process. Therefore, it is an example of irreversible process. If we apply second law of thermodynamics for the throttling, we will get entropy change of universe must be greater than 0, which can be written as entropy change of the system during throttling plus entropy change of the surrounding must be greater than 0. Here, entropy change of the surrounding will be 0 as no heat transfer takes place during throttling. It is a common assumption of the throttling. So, entropy change of the system during throttling will be greater than 0. So, we will say that during throttling, entropy of the system always increases. If we apply first law of thermodynamics for the throttling, that is a steady flow energy equation, we will get the mathematical expression shown in diagram. Here, work done is equals to 0 as we do not get some work from the throttling. Q12 is equals to 0 as it is a common assumption that in throttling the process is adiabatic. The change in kinetic energy and potential energy can be neglected as they are very small term compared to enthalpy. So we will get the relation H1 is equals to H2, that the enthalpy at the inlet will be equals to enthalpy at the outlet. So during throttling, enthalpy of the fluid remains constant. For ideal gas, we know that the enthalpy relation is mCp T2 minus T1, so that will be 0, and we get T1 is equals to T2. Thus temperature will remain constant. If you found this information